So, good evening to everyone, and today I'm going to present to you about the topic of my presentation today, which is about drag coefficient and air density. So, for the introduction, we have drag coefficient and air density. So, what is both of these elements? So the first one, which is drag coefficient, it is a dimensionless number that quantifies as aerodynamic drag force experienced by a vehicle as it is moved through the air. This coefficient is a critical factor in determining how easily a vehicle can cut through air, and thus it directly impacts the vehicle fuel efficiency, top speed, and overall performance. Is a formula for drag coefficient, which is 0.5 times by rho times area times velocity over 2. Velocity over 2. And then we have air density. Air density is a crucial parameter that affects the aerodynamic force acting on a vehicle as it moves through the air. Air density, or rho, is mass per unit volume of air and is typically measured in kilogram per cubic meter, which is kg per meter cube. In vehicle dynamics, it directly influences drag force and lift force, which are essential for understanding and optimizing a vehicle performance, efficiency, and stability. Next is the objective of the research. The objective of this research is to understand the differences between drag coefficient and air density. And then we have the next objective is to understand how both of them affects a vehicle in terms of performance, efficiency, and others. Then the other application for this element. So this is the finding for this research. First, we have the differences between drag coefficient and air density. For drag coefficient, it is about the shape of the vehicle, how easily or poorly it moves through the air. Therefore, a well-designed vehicle that have low drag coefficient would perform better compared to the vehicle with high drag coefficient, such as a high performance car compared to a truck. Now we have the air density. Air density is about how packed the air is and how much resistance it gives to anything moving through it. So these factors will taken into account if the experiment or research is taking place on somewhere with low or high altitude, the weather, and the location of the testing ground. Now we have the effects. What are the effects when you have low drag coefficient or high drag coefficient vehicle? As for low drag coefficient, it can cut through the air more easily and waste less energy. Meaning, for example, a high performance electric car such as the Rimac Nevera. It can cut through the air with how aerodynamic it is, and at the same time consume less electric power to perform as how the manufacturer wishes it to. Then we have high drag coefficient. It faces more air resistant and needs more power to keep moving. The best example we have is, of course, with trucks, lorries, and other low drag vehicle, other high drag vehicle. These vehicles have very high drag coefficient, which in turn make them consume more fuel and thus affect their efficiency. Well, then we have the effects of difference of air density. First, with denser air or thicker air, there are more air pushing against the vehicle as it moves, which increase drags. So this will apply with the location that have dense air, mainly on the low ground, which could effectively affect a car drag due to how dense the air is. Then we have thinner air, where there's less resistance, so the vehicle moves more easily and efficiently. So this will apply on higher ground, like for example, a pig fight, where racers trying to set the best time setting the best time to climb up through the canyon with there's less air. So the car is designed to take that in mind. How about the other application where drag coefficient and air density is taken into account? First, we have aviation, where the same physics is taken into mind is the design of the aircraft. So the airplane designer aim to make aircraft as aerodynamic as possible to help them fly efficiency and reduce fuel consumption. We know that airplane consumes a lot of fuel for to function, and it is crucial for the plane to successfully deliver the passenger without any risk of running low on fuel. Therefore, the design of the plane must be taken seriously in order to make sure it doesn't run with such high fuel consumption. Then air density. So this is why planes flies high, because at the higher altitude, which more people known as flying above the cloud, uh, whereas the air is thinner, therefore is less drag is applied to the plane, which will make the air resistance lower, saving more fuel and allowing faster travels. So moving to the discussion, we have the relationship between speed and drag. So drag force increase exponentially with speed, meaning that As a vehicle or object move faster, drag becomes much more intense. So doubling the speed doesn't just double drag, it actually increases it by 4 times. This is why high-speed vehicles like race car or aircraft put significant emphasis on aerodynamic and minimizing the drag coefficient. If a small reduction in drag can make a difference in high speed. Then we have impact on weather on air density. Temperature and humidity in the atmosphere can subtly change air density, impacting how a vehicle performs. For instance, hot, humid weather reduces air density slightly, which can lower drag. But this lower density also means there's less oxygen, which can slightly affect engine performance in internal combustion vehicle. They also have cold weather, which result in denser air, which increase drag. For car, this might mean using more fuel in the winter due to increased drag and potentially additional mechanical resistance from colder fluid and parts. For the third, the drag coefficient optimization in different vehicle types. We have, like for an example, passenger car, where the automakers aim for a balanced drag coefficient to ensure both fuel efficiency and stable driving experience. They use shapes that provide decent airflow without making the vehicle too costly to produce. And then we have electric vehicles or EVs. EVs are particularly sensitive to drag because higher drag means reduced range on a single charge. This is why many EVs, such as Tesla Model S or Lucid Air, are designed for very low drag coefficient. Then we also have the trucks and commercial vehicles. These are generally boxy and have a high drag coefficient, so design improvements like adding fairings, roof reflector, and side skirt help streamline airflow and improve fuel efficiency. Then we have active aerodynamics and adaptive system. Aerodynamic, active aerodynamic that we can find on some high performance and luxury vehicles is where part of the vehicles like spoiler or the air vents adjust automatically to produce drag or to reduce drag or increase downforce depending on speed. And then we have the adaptive cruise control. Vehicle with adaptive cruise control system can adjust speed based on resistance detected, which directly optimize fuel or battery usage. So, for the conclusion, in conclusion, drag coefficient and air density are both essential in understanding and optimizing an object movement through air, but they represent distinct factors in aerodynamic. Drag coefficient is a measure of how streamlined an object is depending on its shape and surface characteristics. It determines how easily or efficiently an object can cut through the air. On the other hand, air density describes the thickness or heaviness of the air itself, influenced by environmental factors like altitude, temperature, and humidity. While the drag coefficient is specific to the object and remains constant under the same design, air density varies with external conditions and affects how much resistance the object encounters in a given environment. Together, these two factors shape the aerodynamic forces that impact speed, fuel efficiency, stability, and energy use across many applications, from automotive and aviation to sport and renewable energy. This is the reference that was used in this research, and that will be all. Thank you.